Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve some exponential equations. In fact, we are going to solve 3 exponential equations of the same type in this single video. That sounds pretty exciting, so let's get right on to them. So the first equation is 25 to the power of x equals 10 to the power of x plus 4 to the power of x. And the second one is 10 to the power of x equals 25 to the power of x plus 4 to the power of x. And the third one is now 4 to the power of x equals 25 to the power of x plus 10 to the power of x. Okay, so the first one, notice that 25 equals 5 squared, 4 equals 2 squared, and 10 equals 5 times 2. So we can write 5 to the power of 2x here equals 5 to the x times 2 to the x plus 2 to the power of 2x. And now, let us divide both sides with 2 to the power of 2x. Then on the left hand side, we have 5 to the power of 2x over 2 to the power of 2x. And on the right hand side, we have 5 to the power of x over 2 to the power of x plus 1. So we have 5 over 2 to the power of 2x equals 5 over 2 to the power of x plus 1. So we can use the substitution. Letting 5 over 2 to the power of x as t, we have t squared equals t plus 1. Now before we go any further, let us think about the range of t. Whenever you make a substitution, it is always a good practice to check the range of the newly introduced variable. In this case, t is positive for all values of x. Now, from the equation, we have t squared minus t minus 1 equals 0. And since t is positive, we only take positive root, which is t equals 1 plus square root of 5 over 2. Changing t back into x, we have 5 over 2 to the power of x equals 1 plus square root of 5 over 2. Therefore, taking logarithm of base 5 over 2 on both sides, we have x equals log base 5 over 2 of 1 plus square root of 5 over 2, which is a positive number. So that was the first equation. Now, for the second equation, the process is just the same. So first we split into powers of 5 and 2, which is 5 to the x times 2 to the x equals 5 to the 2x plus 2 to the 2x. Dividing both sides with 2 to the power of 2x, we have now 5 over 2 to the power of x here on the left hand side equals 5 over 2 to the power of 2x plus 1. Therefore, letting 5 over 2 to the power of x as t, we have t equals t squared plus 1, and of course t is positive, so we have t squared minus t plus 1 equals 0. Here, let us examine the left-hand side, t squared minus t plus 1. Here, let us make a complete square by adding 1/2 squared here. Then, in order to complete this 1, we have to add 3 over 4 here. So this part becomes complete square, which is t minus 1/2 squared. So we have this plus 3 over 4. And this part, t minus 1/2 squared, is non-negative. So this entire thing is positive. This means that this left-hand side cannot be 0 for any real number t. Therefore, in this case, we have no solution. So we have solved the second one. And now, the third equation. So we do the same thing. You know the drill by now. So first, 2 to the power of 2x equals 5 to the power of 2x plus 5 to the power of x times 2 to the power of x. And dividing with 2 to the power of 2x, we have 1 equals 5 over 2 to the power of 2x plus 5 over 2 to the power of x. Letting 5 over 2 to the power of x as t, we have 1 equals t squared plus t, and t being positive. So we have t squared plus t minus 1 equals 0. And taking the positive root, we have t equals minus 1 plus square root of 5 over 2. Which means 5 over 2 to the power of x equals minus 1 plus square root of 5 over 2. So we have x equals log base 5 over 2 of minus 1 plus square root of 5 over 2. And since this minus 1 plus square root of 5 over 2 is less than 1, we now have a negative root. So we have found all the roots, but now let us think about the graphical meaning of the roots for a while. Each root of the given equations are x-intercepts of the graphs of y equals 25 to the power of x minus 10 to the power of x minus 4 to the power of x for the first equation, and y equals 10 to the power of x minus 25 to the power of x minus 4 to the power of x for second equation, and 4 to the power of x minus 25 to the power of x minus 10 to the power of x for the last equation. And using Desmos Graphing Calculator, we can draw these graphs. So this red curve is the graph for the first equation, the blue one is the second one, and the green one is for the third equation. And you can visually check the positive root for equation A, the negative root for equation C, and that equation B has no solution since this blue graph never touches the x-axis. And that was all for today's video. If you enjoyed this video, please try the problem in this other video of mine where I solved an exponential equation very similar to this one. Also, please don't forget to hit that like and subscribe buttons, and as always, I will see you in another video.